Thank you for joining us from wherever you are in the world. My name is Kim Everhart, and I am a member of the marketing team here at Percona. And I want to thank you for taking some time out of your day today to join us for our Percona Server for MongoDB Data at Rest Encryption webinar. So before we get things started with our presenters, I'm going to just go through a few housekeeping items for everyone. So first and foremost, I would love it if you can raise your hand and let me know that you can hear me talking right now. That would be really helpful in knowing that our sound is working. So use your little hand icon and let me know that you can hear what I am saying. And it looks like some hands are popping up. Great. Okay, I'm going to lower the hand icon, and then I'm going to ask our presenters, Michal and Stephen, to also say a few words just to make sure you can hear them. So Michal and Stephen, can you guys just say a few things quickly so they can hear us?
Hey everyone, thanks for joining. This is Stephen.
Okay. Hello everyone, it's here.
Okay, if you can hear that, can you raise your hand icon, please? Okay, it looks like the hand icons are going up. Wonderful. Okay, so I'm going to lower them one more time. We're going to do another quick check, which is, can everyone see the screen? There should be a slide deck with the Percona Server for MongoDB information right there. If you can raise your hands and let me know that you can see our slide deck, that would be awesome. Okay, and it looks like hands are popping up there. Great, I feel like we're on track. So, just a few things before I turn it over to Stephen and Michal. We are recording this session, so it will be sent out within 24 hours, probably a little bit sooner than that, but just so you know that that is going to be an option. Everyone is muted, but we welcome your questions. So if you have any questions during the presentation, feel free to drop them in the Q&A window. Both Stephen and Michal are going to answer questions during the presentation. We normally wait to the end, but they're going to take them during the presentation and answer them as they kind of come in and where it fits. So feel free to submit your questions as we go along. Don't break and to save them to the end. And I think that is it for right now for me. So before I turn it over, Michal and Stephen are two of our technical experts here at Percona, and they're going to walk you through this webinar today. And so, Stephen, if you're ready, I'll turn it your way.
Thanks, Kim. Hey everyone, thanks for joining us today. Welcome to the Percona Server for MongoDB Data at Rest Encryption webinar. Like Kim said, I'm Stephen. I'm a solution engineer for Percona. Today, I'll be giving an overview of Percona Server from MongoDB and Data at Rest Encryption. And joining me, co-presenting, is my teammate, Michal.
Hello, everyone. Thank you for joining us today. My name is Michal Nosek. I am Senior Solutions Engineer here at Percona. And today I will be co-presenting with Stephen. And in the second part of this webinar, I'm going also to show you more like hands-on workshop on how to configure data at rest encryption with Percona Server for MongoDB.
Like Kim said, send us questions during the webinar, during any portion. Start answering these during and after the live demo that Michal is going to do, and anything that we don't get to, we'll include in a follow-up blog post in a couple of weeks. So why should you consider using Percona Server for MongoDB and not just buy licenses for MongoDB Enterprise Edition? Well, there are kind of two main reasons that come to mind: cost and vendor lock-in. First off, Percona Server from MongoDB is free. To get the same enterprise features as Percona Server for MongoDB from Mongo Inc., you need to pay for MongoDB Enterprise Edition. This effectively locks you into using Mongo Enterprise Edition. It also makes it very difficult and potentially very expensive to get off of Mongo Enterprise once you choose to do so. Mongo's own CEO publicly admits that they don't care about empowering the community, but they are solely trying to drive people to pay for enterprise licensing. This is a quote from Mongo's CEO from an interview with Computer Business Review Online. By using Percona Server from MongoDB, your teams are actually empowered by having access to enterprise features for free. Our CEO, Peter Zaitsev, founded Percona with the belief that software should be enterprise grade and free to use. By using open source software, you're not forced to use only one vendor. You're actually given the flexibility to choose the right vendor for you. This is a quote from Peter, which helps to clarify what some other companies are doing with their software. So how do we actually build Percona Server for MongoDB? Well, we start with Mongo Community Edition. It's the exact same code base. Because it's the same code base, it actually makes it a drop-in replacement for Mongo Community Edition. Then we add in things like critical bug fixes, scalability enhancements like profile rate limiting and the Percona in-memory engine. We add in enterprise features like audit logging, log redaction, and encryption. We add in additional community features. And then we go through a rigorous enterprise level QA process, package all of that together, and release it back to the community. Again, because we're building on top of Mongo Community Edition, we are a drop-in replacement for Mongo Community Edition. And our engineering teams can provide bug fixes for Mongo Community or Percona Server for MongoDB. We enable you to use enterprise features, community features, and enhancements, all while avoiding the licensing cost and vendor lock-in. We actually have a guide online and a previous webinar of actually how to get to the process of upgrading from Mongo Community to Percona Server from MongoDB.
So Stephen, maybe I have a question here. Could you explain if it's hard to migrate from Community Edition, MongoDB Community Edition to Percona Server for MongoDB?
Sure, good question. Well, we want the process to be as easy as possible, and there's kind of two ways to go about doing it. The first is an in-place upgrade. So this is where you would stop MongoDB, you would swap out the binaries for Percona Server from MongoDB, check your configurations, and start MongoDB again. The second is a replica set takeover. This is where you'd add a Percona node to the replica set, or you could do an in-place upgrade of a secondary. Then you'd repeat this process for all the secondaries, so they're all Percona Server from MongoDB. On the primary node, you would order an rs.stepdown command. You'd wait for the Percona node to be a new primary, and then you would do an in-place upgrade of the previous primary, which is now a secondary. So as you can see, we have feature parity for the most used enterprise features from Mongo Enterprise Edition. Percona Server has external authentication with LDAP and Kerberos, auditing, which allows you to track and log user activity on a server, log redaction. This prevents writing sensitive data to the diagnostic log by redacting messages of events before they are logged. We have wired tiger hot backups. This creates a physical data backup on a running server without a notable performance hit. We have data at rest encryption, and that's why we're all here today, and we'll talk about that in the next few slides. We have an in-memory engine, which is just a special configuration of wired tiger that doesn't store user data on disk. The data fully resides in the main memory, making processing much faster and smoother. We have a Kubernetes operator for Percona Server from MongoDB, and I'd say we're leading in that space because we actually released this well ahead of Mongo. This helps automate a lot of the operational functions like scaling, automating backups, and automated node recovery. We also have a backup tool, Percona Backup for MongoDB. This allows you to backup and restore replica sets and sharded clusters.
So Stephen, the question here, are there any features that help you to actually monitor a Percona Server for MongoDB?
Yeah, this is asked pretty commonly actually. So we do have a monitoring tool called Percona Monitoring Management, and like all of our software, it's free and open source. If you wanted to look at a live environment before even installing it, just to see what it is, you can go to pmmdemo.percona.com to check it out. Out of the box, it works for Mongo, MySQL, Maria, and Postgres, and then anything that has a Prometheus exporter, you can actually configure to monitor as well. It's secure by default and can be deployed in your environment. It has a ton of great features. As a security threat tool, it allows for alerting, monitors all your host level metrics, network traffic metrics as well. It has a tool called Query Analytics, so you can analyze all your queries, a ton of detailed performance metrics for Mongo, all about the storage engines in Mongo and replication and a ton of other stuff.
All right, thanks, Stephen. So let me take over here. And before we go deeper into how to actually configure data at rest encryption at Percona Server for MongoDB, let's start with why you even should use encryption and why you should care about it. So first, and the obvious answer that may came to mind is basically security and privacy standards that you have to follow. For example, if you look at HIPAA standard that is related to healthcare data, and it's American standard. If you look at what it says in terms of security and privacy, it says that you have to implement a mechanism to encrypt PHA whenever deemed appropriate. So as you can see, this is of course very vague and rather open to interpretation. If you look at PCI DSS, which is related to credit card information and data, you can look at requirement number 3, which says that you should protect stored cardholder data. And then you can also read that encryption of cardholder data with strong cryptography is an acceptable method of rendering the data unreadable in order to meet PCI DSS requirement 3. Which basically means that PCI DSS is a little bit more specific. And as you can see, encryption is something that is useful to actually be compliant with these standards. One more standard that is a European standard is GDPR. And then if you look at the details, it says that you should implement appropriate technical and organizational measures to secure personal data. So again, it's not really specific, but as practice shows, it's basically important to implement different ways of encrypting data. Now, it is also ethical and moral responsibility to protect the data that people actually store in our systems. If you look more from the business perspective, it is important to protect business secrets from competition as well here. But then, as the history shows, data breach can actually ruin any business that operates in the internet. Stephen, do you have anything to add here about why to use encryption?
Yeah, so in terms of ruining a business, it's quite costly. So a recent study done by IBM showed that an average data breach in the US cost a company $8 million. So it's a simple fix by implementing encryption to avoiding quite a big bill.
Yeah, so that definitely makes sense. I mean, of course, there are like different ways preventing from data breaches, but encryption is for sure one of the important ones. So let's have a look a little bit deeper, and let's have a look what types of encryption you can actually use, especially in the context of the database. So first of all, you may think about in-use data encryption, and what it basically means is that applications that process the data can encrypt this data before even storing it and decrypt once the data is retrieved. So if you look at this on a high level, it basically means that the application takes responsibility for the data security, because anything that is transferred between the application, the database server, is already encrypted, and database has nothing really to do about that here. Then you may have a look at in-transit encryption, and we very often see this as kind of the default type of encryption that comes to our minds when we talk about encryption. And basically, encryption in transit protects your data if communications or intercept while data moves between two services. You can achieve that by encrypting the data before transmission. Then you authenticate the endpoints and decrypt and verify the data on arrival. And if you look at popular methods of encryptions, it's basically SSL and TLS that may come to your mind immediately. But today, we're going to be focused at rest encryption, which is referred to data at rest encryption, basically. And this basically means that the data is stored in its destination, like physically. So if you take that from the database perspective, from the database world perspective, it means that data at rest is a database data files that are stored on disk. So data at rest encryption is about making sure that these data files are not really available to unauthorized parties, unauthorized users. So basically, if somebody get access to the files on the disk in any way, this person cannot really extract any valuable data from them without having an appropriate encryption key. So going a little bit deeper into data at rest encryption methods. So now we're talking about data at rest encryption specifically, and what methods we can use to actually achieve that. First of all is, of course, operating system or volume or block level, you name it. It basically means that we just encrypt the volume or disk using one of the many tools available. And in the end, Percona Server for MongoDB or database in general isn't really aware of any change. and the application isn't also aware of any change. So it basically means that the entire disk or volume is encrypted on the storage level, file system level. Then another method is database level, and this is the encryption method that we are going to discuss today and present today. So we are basically talking about data at rest encryption on the database level. And in that case, it's basically the database, Percona Server for MongoDB, that is responsible for encryption. And that may be also surprising, but the third method that also counts is application level. And it basically means that if you encrypt your data before it's even stored in a database, you can count it for data at rest encryption as well. So let's have a look at pros and cons of database level data at rest encryption. Let's start with good things about that. It basically gives you this inside threats protection, which basically means that if you manage your operating system users appropriately, even though they have access to the operating system, they will not be able to see the data that are stored in your database. It also means that all database features are available. And why is important? Because if you look, for example, at encrypting things on the application side, for things like, for example, full text search may be really complex to solve, as everything is encrypted on the database side, and database has no means to actually decrypt the data. This method of encryption has also very low performance overhead. Of course, it depends on the workload, but in general, you may think about 5 to 10% performance overhead with data at rest encryption turned on the database level. Then in the end, it's also transparent to the application, which basically means that if you have many applications and maybe you can't control all of them, it's good because you don't have to change these applications at all. It is entirely transparent to the applications connecting to the database. And it's also DBA controlled, so you don't really need sysadmin that would be responsible for storage level encryption, for example. If you look at the cons side here, well, basically, if you lose your root user, then it's a threat for this type of encryption. But I would say that it's not that of a big deal because, if you are not in the control of your root user, then it's probably already tons of other problems here. But also, if you have misconfigured database users and permissions, you can also lose the data because whoever can actually connect to the database and execute queries can actually dump this data. So it does not really protect you from that misconfiguration and threat. Then data at rest encryption on the database level is also separate for each node, which is maybe good from security level, but from the configuration level, it may be a little bit problematic. Then if you look deeper how it encrypts the data, it is encrypted only on disk, but not in memory. So whatever is in memory is already unencrypted by the database server, by Percona Server for MongoDB. And last but not least, of course, if you lose your encryption keys, then it's a huge risk. So something to keep in mind, as well here.
So at a high level, I'll talk about how Percona Server from MongoDB data at rest encryption works. It uses what's called the envelope encryption model. So this is where each database is encrypted with a separate key, which is stored in the internal MongoDB key store, which is encrypted on disk. These keys never leave the server. The internal MongoDB key store, or all of your database encryption keys, are encrypted then with a master key. The master key should be stored external to the server. We'll demonstrate this today by using HashiCorp Vault. It's important to note that neither database encryption keys nor the master encryption key are replicated to other members of the replica set or sharded cluster. Also, each and every node has to be encrypted independently.
All right, so let's have a look at the hands-on part of today's webinar. So we prepared basically a very small infrastructure on AWS EC2 virtual machines, and it consists of 2 nodes of Percona Server for MongoDB that are configured to be a replica set. don't run 2 nodes in productions. You should always run 3, but it's good enough for the presenting purposes here. And then we also have one node that has HashiCorp Vault installed. And basically, HashiCorp Vault, or you may refer to it as Vault, is a tool for securely accessing secrets. And you may look at a secret as anything that you want to tightly control access to, such as API keys, passwords, certificates, files, or actually encryption, master encryption key for Percona Server for MongoDB. And Vault is a very secure way of storing that. It provides a unified interface to any secret while actually providing very tight access control and recording a very detailed access log. So what are we going to do today is a couple of things, couple of steps we have here. So first of all, we are going to demonstrate the easiest method of data at rest encryption. We are going to encrypt one of the nodes of our replica set with locally stored key file. Then in the second step, we are going to configure HashiCorp Vault to work with Percona Server for MongoDB. So it will be already installed, but I will show the configuration of that to make it work with Percona Server for MongoDB. Then we will configure node encryption with master key that is stored externally in Vault. And this is definitely something that is recommended to do in production this way. And as the last step, we are going to perform master key rotation, which is a standard security procedure. You should not be using your master keys for too long. All right, so I think we are ready to actually go to the demonstration part. Just share my screen.
And just a reminder, we do have Percona Live online coming 20 through 21 October. We have various Percona Tech Days coming up as well. So keep an eye out for those.
All right, so can you please confirm that you see my terminal window? Raise your hand if you see the terminal window. And you can hopefully also read the text here. Okay, are we good? All right, so as I said, we have a couple of things here actually. So first of all, in the left top corner, the currently active terminal window, you have replica set node 1, which is basically right now a primary in our replica set. So if I look here at Mongo, you can see that this is right now a primary. In the right top corner, we have a second node of the replica set. So this is Percona Server for MongoDB. That is a secondary node right now. So if I log in here, you can see that this is secondary now. And the third window here at the bottom is basically HashiCorp Vault node, where we are going to configure HashiCorp Vault. So let me start with actually node 2 here. So I have a script prepared that is basically listening data from one of the collections that I put there. I try to execute that. Now you can see a couple of documents here, very simple documents with basically name, a key, and hello world in each of them, right? And now what I'm going to do, I'm going to try to find this hello world string in the MongoDB data files, right? So in order to do that, I have another script to make it simple here. That is going to actually go through the data files of Percona Server for MongoDB and try to find hello world strings. So as you can see here, I found one of the binary files and its location is /var/lib/mongo/collection with WT extension, which basically means it's a wired tiger storage engine data file. And in order to prove that that this data is actually readable there, I can basically try to show you the output from here. And very quickly you can see that even though it's binary file, you can see hello world strings, so you can basically dump the data from this file. And normally you will not observe that because it's compression that is typically enabled. I disabled compression for the purpose of this webinar, so you can see the actual effect of enabling data at rest encryption. So that's why we actually see that. All right, so what are we going to do now? Let me clear the screen here so you can see better. I'm going to generate the key file because we're going to use it locally. So I am generating a key file using OpenSSL random key file, and I'm going to store that in /mongo/MongoDB key file file. So now it is successfully generated. Now I have to do a couple of things related to permissions. So first of all, I need to limit permissions a little bit for that. So I'm setting 600 permissions to this /mongo/MongoDB key file. And the second step that I need to take here is basically changing the ownership of the file. So it must be very limited. So only MongoDB user that we're going to use to run Percona Server for MongoDB can access this file. All right, so that should be successful. Now, the most important step here, as we have this file generated, is to actually edit configuration of MongoDB, Percona Server for MongoDB. So by default, the configuration file that we use is in the /etc/MongoDB conf file. I'm going to use VI editor to edit that. And here, of course, among other options, we are looking for security section that is critical. So I'm going to scroll down to security section. You can see that it's commented out here. I'm going to remove this hash in front. I'm going to add a couple of things. I mean, first of all, it's security section that you can see here. Then we have to enable encryption. We should set encryption cipher mode in the next line. And the most important part here is to actually set the path to encryption key file. So I'm going to set it to the file that we just generated prior to opening this config. All right. So it's encryption key file, and as you can see here, it directs to /MongoDB key file. All right. So that should be it for this configuration. I'm going to save the changes and quit the editor. And what we have to do right now is basically to stop MongoDB process. And why we have to stop MongoDB process is because you can't really re-encrypt the data that is already in the database. So we need empty database to enable encryption, and only then we can really enable it. So I'm going to stop MongoDB process here. Should be successfully stopped now. And I have another script prepared that is basically going to remove all WiredTiger files from MongoDB MongoDB data directory. So I am deleting that data now, and only now I can actually restart MongoDB. Right. So what we've done is we changed the configuration, we stopped MongoDB process, we removed all the data files, and then we are going to start a MongoDB process now. Okay, so it started probably successfully as we don't have any error output. So as you know, we have a replica set here. So the data should be synced from node 1. So to kind of try to prove that, I'm going to query the database again with my script to show you the output of my test collection, which has all the hello world strings in a name property of each document here. So we have data synced. If you open the Mongo client here, if you connect to Mongo, you see that it's replica set 0 and it's secondary node right now. So we have it connected. Now, let's try to prove that we have encryption at rest enabled actually here. So if I try to find the same hello world strings in MongoDB Percona Server for MongoDB data files, it will return nothing, which basically means that now you can't really read that. And we not only successfully enabled that, but we proved that the plain text data is not there anymore. All right, so let's now go to the step 2 of this presentation. Yeah,
Michal, just to clarify for people who maybe don't use Linux a lot, so basically, because you're not getting a result for this, that means you're not finding anything, correct?
Yes, exactly.
Okay,
so there is no file without hello world string with hello world string in MongoDB data files.
Got it. Thanks.
All right, so let's go ahead to the second step of this presentation. So I will make this window a little bit bigger so you can see better the Vault node. So we're going to now basically, well, maybe let's start with replica set node 1. So what we have to do to actually encrypt that, I'm going to make it secondary first before we continue. So let me just connect to it. It's primary, so I'm going to step down this node. The operation is successful. We see OK here, and we see now here in the prompt that is secondary. So I'm going to exit now from here, and now go ahead and switch to Vault node here. So what we basically need to start with is starting Vault node. So starting HashiCorp Vault here on this node, we'll go with Vault server command and config file that is default here. I will start it in the background. It is starting now. We should see the output that it started successfully. So we here have the output with the address and the port that it's listening on. That is going to be important a little bit later. All right, so it seems like we are all set with Vault running in the background. Now we are going to initialize Vault server to prepare it for storing our secrets. I use Vault operator init command. And you can see now that there is like a lot of output here. So what is happening here is basically we generated a couple of tokens that are important to us. So first of all, we have a list of unseal keys. So these are keys that are required for us to log into Vault server to basically unlock it for the first time or after restart. So this is very important. And the second thing is initial root token that is also needed for us to use Vault later on. So I'm going to go ahead and copy that just in case something happens here with my session, so I don't have to generate that again. It's very important to store these keys. And now we are going to start to unlock, which means unseal Vault server. So I'm going to use command Vault operator unseal here. And I'm going to use keys generated before, so these keys. And in order to unseal the Vault node, we actually need to do it 3 times, and each time with different key. So I'm doing now that with the first key. You can see that unsealing progress is right now 1 out of 3. I am going to do it with another key right now. So again, the Vault operator unseal. I'm going to copy entire unseal key, and paste it here. Now you can see the progress is 2 out of 3. And of course, we need to do it once more to actually successfully unseal it. And we can take, for example, unseal key 5. It doesn't matter here. So I took unseal 5. You can see some log messages, but what is important is that sealed is now set to false, which basically means that our Vault server is ready for us to log in. So I'm going to use Vault login command. And now I'm taking the root token from one of the previous commands. So if I scroll up, this is the root token that is required to log in for the first time. I'm pasting that here. And you can see that we're successfully logged in to the Vault server. So right now, what we have to basically do is to enable appropriate secrets engine. So Vault supports different secret engine, and for different purposes, you may use different engines. But to make it work with Percona Server for MongoDB, you actually need to use key value secrets engine version v2. And you can, of course, find more details in the documentation of Vault, but this is what I'm going to enable right now. And I'm going to do that under path secret here. This path is important. We're going to use that later in configuration. So I'm enabling that, and you can see that there is success. Key value version 2 secrets engine at secret path is now enabled. So what I'm going to do right now is I'm going to write the Vault policy. So we are not going to talk about policies much, but this is basically how the specific application under specific path can access Mongo secrets, and which Mongo secrets it can access. Can it update these secrets, delete these secrets, and all these types of things. So it's basically about access policies. So I'm going to write it now. It's uploaded successfully, and we are going to create token that is going to be used by Percona Server for MongoDB to access Vault. So I am enabling that. I'm creating that token right now. You can see that I'm using Vault token create, and I specify policy parameter, and I set it to Mongo policy. And what we're going to actually need later on is this token that we just generated. So I'm going to copy that so I don't lose it if something happens to my session again. And we are ready when it comes to Vault. Now, I have also prepared the certificate file for secure connection here. So what I'm going to do is I'm going to copy that file to my replica set node 1, which basically means that I'm going to use SCP to do that. I just need to grab the private IP address of that node, as you can see here, and then specify appropriate path. I see a typo here. So let me just fix that quickly. I'm going to copy that from this Vault node to Percona Server for MongoDB replica set 1. Okay. I'm doing that for the first time. I need to put password here. Hopefully it's successfully copied. So if I check here, we have this support CRT certificate file ready. All right, so I'm now going back to, so the Vault configuration is basically ready. Now I'm going back to the replica set node 1 again. I will make that screen bigger so you can see better. So what I have to do here is to actually take my token that I generated in one of the previous steps. I have that copied, so I'm going to paste that here. And we are going to basically write it to /mongo/vault token file. So similarly to the file that I had stored locally. I'm writing this token there now. Just double check if that's the appropriate token, but it seems that we are good. And it's basically this token that we generated in one of the previous steps. So we have the token. We have to do similar things that with the local one. So I'm going to set permissions. And I'm going to basically change the user of this token. Then I'm going to take my certificate file and move it to the same directory as well. So I'm moving my support.crt to /mongo/support.crt. We have it there. And then again, we need to edit the configuration. So similarly to what we've done on the previous node, I'm going to use VI editor to edit etc/mongod.com. And of course, as we said before, this configuration of data address encryption is separate on each and every node. So what I'm going to do now, even though it's the same replica set, I'm going to basically configure that from scratch. So I'm going to remove that, uncomment that. We have this security section here, and this configuration is going to be a little bit longer. So first of all, we enable encryption. Secondly, we need to add Vault section here. And as we have Vault section, we need to specify server name. You can see here. Let me just grab the IP and the private IP of this server, which should be basically this. Then we specify port, which is going to be 8200. Then we specify token file, and token file is the one that we actually stored in /mongo vault token. So we have token file here. Then we have secret path. So we enabled secret engine under secret path on Vault. So this is exactly this. Data is something that you need to put there. This is according to key value store v2 documentation, and then we are going to store Mongo secret, which is going to be our master key. And one more thing, we're secure SSL connection certificate file, which is /mongo/support_crt. Let me quickly have a look if we have everything. Security section, we enable encryption. We have Vault section with all the Vault configuration here, token file, secret path on Vault node, and certificate. So it seems like we have everything right now here. All right, so let me just store that. And now we have similar situation to what we had previously. So we can't re-encrypt the data. However, now our node 2 is right now secondary. So, is primary, of course, I'm sorry. So node 2 is primary right now. And node 1 is secondary. So I'm going to stop MongoDB process. I'm going to remove the data files. So data files are removed now, and I'm going to start the process again. So now what should happen is actually it should connect to Vault, it should generate the master encryption key locally, store it in Vault, encrypt the data, and then start successfully. No error here, which is probably a good sign. Let's see if we can query the database. We see the data is still here, so it was synced from RS node 2, which is here. We have all this hello world data. And even though we have disabled compression here, we should not be able to find any hello world strings, which basically means that data is encrypted. And that actually completes this second step. So now we configured the Vault node, and we configured one of the nodes of our replica set to use Vault to store its key file. And right now you can see that you have these two separate nodes. One has a locally stored key file, and the second one is basically Vault.
Michal, could you run a cat on the encrypted wired Tiger file to show what it would actually look like?
Yeah, I think it shouldn't be that shouldn't be a really big problem. It's just I'm not sure if I know what the file should be, because it may be different here. However, let me just quickly have a look. So we basically would need to make it sudo and go to var lib and Mongo. So this is data files, and you can see different wired Tiger files here. And previously it was stored in this, so there is very high chance that as it's the same data is going to be stored here. So I can try to cut this file, but as you can see, this is totally different. And yeah, I hope not to. My console does not hang, but you will not see hello world anywhere here right now. So this is basically encrypted. All right, so that means that we're ready to actually go to the last step, which is encryption key rotation. And what it means is that when we want to rotate the key, we basically, Percona Server for MongoDB generates a new key. It stores the new master key in Vault, and it re-encrypts the key store using this new master key. So in the end, entire dataset is not re-encrypted. So as you remember from the presentation, we have envelope encryption model, which means that each database is encrypted with different with different key. Then these keys are stored locally in the key store, and there is master encryption key that encrypts this key store. So the only thing that got re-encrypted is this key store, which means we don't need to delete data or do any other advanced operations here. So let me show you how it works in practice. I'm going to open the MongoDB conf file again. I'm going to scroll to our security section that you can see here. And I'm going to basically add one line. And this one line is rotate master key equals true. Now I'm going to save these changes. I'm going to this time restart MongoDB process, so I don't have to delete anything. I just restart it. There we go. We have some error, which is still good, right? As we are on the 4th exercise and we still had no problems so far, but it is actually expected. So what it means that it failed to start MongoDB, but it doesn't mean that it's that our master key is not rotated. So in order to prove that, I'm going to tail the MongoDB log file, which is /var/log/mongo/mongodblog. And you can see here that, let me just find it because it's not that easy. We should see basically here that it is re-encrypted successfully. So let me just find that. I can't see it here. Oh yeah, there we go. I'm so sorry. So you can read it here that even though it exited with exception because start command wasn't successful, you can see that master key rotation finished successfully, and then it exited with error code from Mongo, so it is not started. So we rotated this successfully, and as we rotated this successfully, we can go back to our Mongo config file, and we can basically remove that line or change it to false. Doesn't really matter at this stage. And now, as we change that, we can basically, oh, I'm so sorry, it's the wrong command. So it should be restart MongoDB. And now it should start successfully. And that basically completes the workshop. So what we've done right now is we rotated a master encryption key, which means that it got regenerated on the server here, stored in HashiCorp Vault, and then the key store locally was re-encrypted.
Great. I'll read through a couple of the questions I've been getting. So Michal, I answered most of these. If you want to add anything to this, let me know. So first question was, where do we keep the encryption keys? I said, we're showing this with HashiCorp Vault today, and generally we see people using this, HashiCorp Vault, but generally just in a secure location.
Yeah, I would just add that the best practice is not really to store it locally as we presented. So, it is possible, but the best practice is to store it externally to have increased security.
Okay. Does data encryption support a version less than MongoDB 4.0? So it's for the Wired Tiger storage engine. It's been available since Percona Server for MongoDB 3.6. I got a question about the overhead implications of encryption. I said it's typically low, maybe around 5%. Someone asked for documents for these exercises. There's nothing publicly available, but this is being recorded, so you can watch the webinar again and walk through the steps. If you have to remove all the data, does that mean that each secondary in production will need a full initial sync after restarting MongoDB with the new security features? So it said yes, you would do this for the secondaries, then you would step down the primary and do it on the former primary.
Yeah, so this is basically because you can't re-encrypt existing data. And what you can do, of course, you can also play around with backups to make it maybe faster. But in general, you need to load data from scratch to enable data encryption at rest.
Yep. If I convert a node to Percona Mongo, can I convert it back to Mongo Community Edition later if I find an issue with Percona Mongo? So yeah, you can do that, but we are built on top of Community Edition. I got what's the code in a .sh files. I said you're just running queries on the database to show hello world.
Yeah, I mean, basically it's for me. I can show here. It's for me not to really make any errors. So these SH files, like QueryDB, for example, it basically got JavaScript file, so it's a bit more complex, but I can show you. QueryDB is basically executing this, so it's just for me to make these things faster. So there is no really magic. It's just standard MongoDB commands and maybe not only JavaScript, but if you look at remove data sh here, so if I show you this, I basically remove the data. So yeah, that's a little bit of a help to avoid typos.
I got a couple unanswered questions. So if we use a multi-node setup, do we create a separate master key for each?
If we create a multi-node setup, if we need a separate master key for each, is that the question?
Yes, for each.
Okay,
each
so
node, yeah.
You can use the same encryption key. I mean, store it in the same place theoretically in HashiCorp Vault, but the best practice is to use separate key for each and every node. Now, HashiCorp, is a tool that helps you to really, manage this secrets, which means that you don't have extra overhead by maintaining additional keys, which is great because you can have separate keys and then you can maintain them easily. So while you can use single key, it is much better and recommended to use separate key.
Great. I got a question about data encryption being supported with Vault since Mongo 3.6. So I know for the wide target storage engine, Percona Server for MongoDB since 3.6 has encryption. Does PSMDB support client-side encryption?
Yeah, so I may answer that. So no, Percona Server for MongoDB right now does not encrypt client-side encryption like a feature, because it's usually something that you do on the application side, which basically means that, of course, if you encrypt your data on the application side, then it's fine. You can use it with data address encryption, but typically it is not database responsibility to do encryption.
Another question, how long does the master key rotation take with respect to the data size? Does it matter?
No, it does not matter because how the encryption works. So each and every database is encrypted with its very own key, and this key is stored locally on the database node in a key store. And then this key store that stores these local keys is encrypted again with this master encryption key that is only stored externally, which basically means that it is just this key store that is re-encrypted, not the data on the database node, which of course results in the fact that it doesn't matter how much data you have, you just re-encrypt the key store, which means that it is very, very fast as we presented.
And then last question, can we use AWS KMS instead of Vault Server?
So at this point, the answer is no, you can't use it directly. However, we have plans to add support for KMS as well, hopefully in the near future, but we can't share the data at this point.
Last question I have is, what happens with the admin database after encryption is enabled?
That's an interesting one. I would say that it's encrypted as all the other databases. However, I think we need to follow up and answer and check that, because I'm not sure. Maybe you are sure, Steven. So
yeah, I'm not sure with the admin database specifically. We'll definitely follow back up with an answer for that one. And that looks like most of all the questions. We have these recorded, so we will re-answer these in a blog post in case you missed something. And then feel free to comment on that blog post if you have further questions, and we'll get back to you on that.
all right. Then thank you very much for attending.
All right, thank you guys. They said my mic wasn't great, so I'm not going to talk too much. So, but thank you everyone for joining us, and thank you, Michal and Steven. That was really great. I really enjoyed it, and I hope you guys did too. I hope to see you in the next one, and don't forget we have MongoDB Tech Days coming up next week for you, and there's a link in the chat, so sign up, and we hope to see you there. Thanks everyone. Have a great day.